Hi students, now we'll discuss about Smith chart. Smith chart. Simply, Smith chart is mainly used to determine the values of reflection coefficient, that is K value, and VSWR, S value, and Z maximum, Z minimum, and normalized admittance, length of stub, location of stub, etc. These are the main parameters, those will be used. And here mainly we are calculating here reflection coefficient, VSWR, Z maximum, Z minimum, and normalized admittance. These are the parameters we are calculating right now. And apart with this Smith chart is also used to find the values of length of stub as well as the location of the stub also. These are the applications of the Smith chart. To determine these values, we are using Smith chart. Now, coming to the point, the existence of Smith chart is like this. Here simply, Smith chart is a combination of two orthogonal circles. Two orthogonal circles. That means simply here we are having two orthogonal circles. One is called R circle, that means real value circle, and the second one is called as X circle, imaginary value circle. Whenever these two circles are orthogonally plot, then we will get Smith chart. I will show to you here how the R circles and how the X circle is this. Now look at here, it is the existence of Smith chart. Now when we see this, look at here, some circles are existing like this, some circles are there. That means simply I will draw here. When we see this like this, here some circles are having like this. These circles are called as a R circles. And again look at here, some circles are having like this. That means here like this, in this direction. Look at here, these are all the circles. Those circles will be ends at infinity. That means simply those circles will be having like this. These circles are called as a X circles, imaginary circles. When we combine these two, the Smith chart will be forms. This is the Smith chart. Just look at here. Here we are having R circles as well as X circles. R circles are there like this, and as well as X circles are there. These are all are X circles, and these are all are R circles. And look at here. This axis. Look at this axis. This axis we are having some values. Here it is 5, 4, 3, 2, 1.8, 1.6, like this. Above all the values, for this line, all the values are positive values. and for this line all the below values are negative values. Those are the positive values and these are the negative values. Above this axis are the positive values, below this axis are the negative values. And look at here, the scale existed here at the bottom of the chart. Here it is SWR line is this is the SWR line, and next reflection coefficient line is this, it is the reflection coefficient line. SWR line, reflection coefficient line, these two lines are used here. We need these two lines. And at the same time, just look at here, angle of transmission coefficient in degrees, angle of reflection coefficient in degrees. Look at here, that means this value, this line above values will be gives us the angle. So angle of reflection coefficient is determined with the help of this line. Just the line is entirely distributed along the plot. Just look at here, along the plot the line is existed. Along the plot the line is existed. That is angle of reflection coefficient. And these are the few parameters we had to observe here. Now before starting to draw our Smith chart, first of all we had to find normalized impedance. That is the important parameter you had to calculate before drawing to Smith chart. That is, normalized impedance can be given as simply ZL by Z0. Here in the problem they will give ZL value, at the same time Z0 value. We have to find the value of ZL by Z0, then we will get the normalized impedance. For example, I will show to you one example. If ZL is equal to 50 plus J100 and Z0 equal to 50 is the Z0 is given and ZL is given as 50 plus J100, then here we are getting 1 plus J2, 50 by 50 1 plus 100 by 52, 51 plus J2. Here it is a R value is this, R value 1, X value is 2, R value is 1, X value is 2. That means on the real axis circle we have to consider 1, on the imaginary axis circle we have to consider 2. So look at here, I will show to you to identify 1 in R value. Just look at here, R value should be identified on this axis, real value should be identified on this axis. Just look at here where 1 is located. Here is 4, 3, 2, 1.8, 1.6, 1.4, 1.2, 1. It is the R value. So now we had to highlight this circle. We had to highlight this entire circle. Just we had to draw a line on this entire circle like this. Just look at here, I am highlighting the entire circle at this side and the same this side. Just look at here. I have highlighted the circle, one circle. That means because R value is 1, so I have highlighted the R circle. And similarly, X value is 2. Here we have to identify what is the polarity of the X here. Here the polarity of X is positive. Then I have initially told to you that the positive values is above the level, negative values is below the level. So here plus 2 has to be taken above the level. Just we'll search for 2 in above the level. We'll search for 2. Just look at here. Here it is 5, 4, 3, 2. Here is 2. 1.8 like this. This value will be goes 2. Now I am highlighting this 2 circle. This 2 circle is here now. This is the circle. Just highlight it. Just highlight it like this. Highlight it. Yes, with a free hand and with a pencil we had to highlight. It is one circle and it is R circle and it is X circle. Now the next important step is here. We had to identify the intersection point of these two circles. This is the intersection point. It is R circle, it is X circle. Just write it here, R circle, and it is X circle. R circle, X circle. Those two circles are intersecting at this point. Now the next point what we have to do is we have to take compass. Now place compass needle at 1. For any problem, for every problem, we have to place compass needle at 1. Just look at here, at this point. At this point, we had to place the needle. One value is here now. One value. We had to place the needle of the compass here, and the needle of the pencil is here. Intersection point. We have intersection point here. The compass needle is here. The pencil needle is here. That like this. Take this radius and draw one circle like this. Take this radius and draw one circle. That means we're having a circle like this. We have to place the compass at this point and pencil needle at this point. We had to choose this radius and we had to draw the circle. This circle is called as VSWR circle. This circle is called as a VSWR circle. Next, with this circle, we have to identify all the values. What we have discussed here is reflection coefficient, VSWR, Z maximum, Z minimum, all the values, normalized admittance. All the values has to be determined with the help of this circle. Okay, this is the VSWR circle drawn. And I will show to you another example to find all those values. I will show it to you there. And I'm taking another Smith chart. In the problem, they have given ZL equal to 5 plus J25, Z0 equal to 50. Those are the values given in the problem. Now I had to identify all the parameters. So before starting my problem, I had to find normalized impedance. ZL equal to ZL by Z0. ZL value is 50 plus J25 by 50. 5 by J25 plus 50. That is equal to 5 by 50 plus J25 by 50. That is equal to 5 by 50 is nothing but 0.1 plus 1 by 2, that is 0.5. 0.5. Here this value is R value, this value 0.5, sorry, 0.5 is X value. Here X value is also positive, R value. Now I had to search for 0.1 and 0.5. Just come to the plot. First identify the 0.1 circle. Just look at here, 1.2 values will be rises. So 1, 0.9, 8, 7, 6, 5, 4, 3, 2, 1. Here is 0.1. Now we had to highlight this circle. Just look at here, it is 0.1 circle. I am highlighting 0.1 circle, highlight it in both sides. Now 0.1 circle, here this side also 0.1 circle. Just highlight it. Just you have to do it carefully. Just I have given here random 0.1 circle. Next value is 0.5, positive value. So again I had to search for 0.5. Look at here, here is 2, 1.8, 1.6, again come here, 0.5 is here. Now highlight it, 0.5 circle, highlight it, 0.5 circles. Now the intersection point, it is R circle, it is X circle, intersection point is this, that is the intersection point. Now take compass, then place compass needle again here at 1, place compass needle at this point, take the radius of and pencil needle at this point, take the radius of this one, that means from this point to this point, to this point, take the radius like this, and with this radius draw one circle, one VSWR circle like this. That is the VSWR circle. I am drawing one circle. That is the VSWR circle. VSWR circle. It is VSWR circle. VSWR circle. Now we had to find K value initially. Now with the help of protractor, just look at here carefully. With the help of protractor, from this point onwards, place 90 degrees. From this point 90 degrees, drag the line. Drag this line like this. Line like this. From this point to extend one line in this direction. That particular line, extend this line in this direction. That particular line strikes to SWR and reflection coefficients. SWR and reflection coefficients at the value of approximately this point. Just look at this point. I am showing here randomly, random point I am showing. This point, that means 5, 10, 10, below 10, before 10, that means it's approximately 9. Just I'm showing only random. When we drawn exactly, it will be cuts at 13. At this point it will be cuts 13. And at the same time, look at here, K value is here. In between, it is the reflection coefficient value in between 0.7 and 0.7. 0.8. That means it is 0.78. It is K value. K equal to 0.78. In between these two, 0.7 to 0.8. So I am assuming K equal to 0.8 and VSWR equal to 9. VSWR equal to 9 I am assuming. Two values. We have already calculated two values. Now the next value is Z maximum. Z maximum is nothing but this point where VSWR circle strikes to this center line. This center line is here now, where VSWR circle center line, that is Z maximum. Z maximum, or we can also write here VSWR is equal to Z maximum. Z maximum, the same value of VSWR, that is Z maximum. And at the same time, Z minimum is this point, that is where VSWR circle touches to the center line. VSWR circle touches to this center line, that is this point. It is the Z minimum. It is Z maximum at this side, Z maximum, this side Z minimum. Z maximum, Z minimum. And you have to identify normalized admittance also. Normalized admittance. And at the same time, angle also. Angle of reflection coefficient. Those are the 2 points we had to identify. So for that, we had to draw one line from this point to intersection point. Look at here carefully. Origin 1 point to intersection point of R circle and X circle. We had to draw a line in between center origin to intersection point of R circle and X circle. Now I draw a line like this. Draw a line with the help of scale. Please draw a line with the help of scale and extend it. Just look at here. Here we are calculating 2 points. One point is this, another point is this. Extend this point like this and like this. And look at here, this point where this line cuts to the VSWR circle. Yes, this line cuts to the VSWR circle. That is the normalized admittance, and I will show to you how much it is. And look at here, first thing I will find R value. Near to this I am having this circle and this circle, just in between these two circles, this intersection point. So come here, this circle, come here, this circle, this one, it is 0.6 circle, and this circle is 0.5 circle. In between these two, it is the intersection point. In between these two circles I am having intersection point, so I am assuming that one as 0.5 to 6 in between those two. So 0.55, that is R value. Plus, sorry, not plus, the values is below the reference level, so minus. And look at here, X circle value, it is one X circle, it is another one X circle. Two X circles are flowing in between these two, that means 1.8, 1.6, 1.7. it is 1.7 circle, it is 1.8 circle. In between these two, so minus j 1 point near to 1.8. So normalized admittance is 0.55 minus j 1.8. It is normalized impedance. Admittance. Normalized admittance. That is the next point. And the last point is here, angle of reflection coefficient. Just look at here. This one will be strikes to this line at this point. Strikes to this line at this point. Here, look at here carefully. Strikes to this line at this point. Here the angle is, look at here, 65. In between 65 to 70. Near to 65. So it is 61. Near to 61. So angle of reflection, already we have discussed. The reflection coefficient K value is here and angle is 61 degrees. K equal to 0.78 at an angle of 61 degrees. Like this, we have to calculate all these values. All these values we have to calculate. It is the one of the example. Another example, find VSWR, reflection coefficient and normalized admittance for a transmission line with normalized impedance. Here in this problem, they are not mentioned ZL or Z0 values. Directly they are given ZL by Z0 value. That is called as normalized impedance, already given. That value is 0.3 plus j 0.5. That is the normalized impedance. Direct value they have given in the problem. So Z equal to 0.3 plus j 0.5. Then here R value is 0.3 is the R value and X value is 0.5. That is positive X value above the level, positive X value. Now I'll identify 0.3 and 0.5. 0.3 on real, 0.5 on imaginary. So 0.3, look at here, Smith chart, 0.3. Here it is 1. 1 is the center, 0.9, 8, 7, 6, 5, 4, 3. 0.3 is here. Just look at here. 0.3 R circle. So highlighting this R circle. Highlight it. Highlight the R circle just like this. I have highlighted the R circle like this. And the value of X is 0.5. So 0.5, that is plus 0.5. So we have to search in above. Just look at here. 2, 1.86, 3, here it is 1, 0.9, 0.5, 0.5. It is the circle. It is the X circle. 0.5 circle I am highlighting. Highlight 0.5 circle. Now again take compass. Place compass needle at 1. Here at 1. Place compass needle at 1 and take the radius from this point to this point, intersection point. It is R circle. R circle is this and it is X circle. intersection point is this, both intersection point. Now take the radius from this point to this point, this point to this point as a radius, and draw VSWR circle like this with the help of compass. Please draw with the help of compass. VSWR circle is like this. Now look at here, this point is Z maximum, this point is Z minimum, VSWR circle touching point Z minimum. And now to find reflection coefficient and reflection coefficient and the standing wave ratio from this VSWR line, with the help of protractor, draw a line like this. Now it will strikes at here SWR is at between 3 to 4 and near to 4, so it is 3.9 VSWR, and reflection coefficient is this point 0.5 to 0.6, but near to 0.6, then it is 0.59 K value is 0.59, and at the same time we have to find the angle of K. So to find angle of K, take a scale and this point to this point, in between these 2 points draw a straight line, and extend this straight line towards this direction and as well as this direction, both the directions. Now look at here, this line strikes at this point. This point is in between 60 to 65 and near to 65, so it is 64 degrees angle. So the angle of reflection coefficient is 0.59 at an angle of 64 degrees. And at the same time, normalized impedance. Look at here, this is the intersection point. Here the R circle, first identify R circle. This R circle will be goes here 0.8, in between 0.8 to 0.9, 0.8. It is below the axis, so minus. Imaginary value will be, look at here, it is the one line, in between these 2 lines. In between these 2 lines, this point is in between these 2 lines, So 1.6, 1.7, 1.65 minus j 1.65. It is normalized admittance. Like this, by using Smith chart, we can find the values of K, VSWR, and Z maximum, Z minimum, and normalized admittance. This is the process of determination in Smith chart.